Am I audible to you? Okay, Adarsh. Okay. So last class we stopped with exponential function, isn't it? And how we can convert this binomial series to an exponential series, isn't it? Do you remember? We had the McLaurin series, and then binomial series also can be written in the form of exponential series by applying the formula of permutation and combination. I think we substituted the formula for permutation instead of combination in binomial series, and then we converted it into the exponential form, isn't it? Exponential series. So if you are asked to write what is an exponential series, you have to write both the series, Maclaurin series as well as the binomial series. Okay, is it clear? Please tell everyone to join first. So I'll share my screen now. Today we are going to discuss problems on this exponential series. So let us look at these two problems on exponential series. Can you see the screen? Can you see the screen? Okay, Taiful. Okay. So now look at this question. Here, this question is related to exponential series. Okay, let us see how to solve this question. See, a ship carries 48 flags, and out of this 48 flags, there are 12 flags of red color, 12 flags of white color, 12 flags of blue color, and 12 flags of black. Total 12 into 4, you get 48 flags. Total out of 48 flags, you have 12 flags are red, 12 flags are white, 12 are blue, and 12 are black. Now 12 of these flags are to be placed on a vertical pole. I want to place these flags on a vertical pole, so in order to communicate a signal to others. So how many flags should be placed on this vertical pole? 12 flags have to be placed on this vertical pole. Say I have red flag. Then another flag is blue, isn't it? There is red flag. There is blue flag. Then another one is black flag, isn't it? So another one is black flag, and let me draw this plain color for white. This is white flag. Okay, so likewise I have to arrange the four colored flags, red, blue, black, and white flags on a vertical pole, and there should be a total of 12 flags. Okay, there should be a total of 12 flags on the pole. So here again they have red, one more red. So likewise there will be a total of 12 flags. 1, 2, 3, 4, 5, 6, 7, etc. up to 12 flags will be placed on a vertical pole, and these flags, the sequence of the combination of these colors, they communicate some meaning to the other ships. So the different combinations of the colors, they communicate some Hello, am I audible to you? Hello, am I audible to you? Ashwin, ഇടയ്ക്ക് ബ്രേക്ക് ആയി പോയാ? അനുരാഗ്, ഇടയ്ക്ക് വെച്ച് കണക്ഷൻ ലോസ്റ്റ് ആയാ? എവിടെ വരെയാ നിങ്ങൾ കേട്ടതപ്പം? Did you hear the question? Did you hear the question? Question കേട്ടില്ല? Question മാത്രമേ കേട്ടോളൂ. Okay. So I'll say the question once again. So ഇതാണ് question. ബ്രേക്ക് ആകുകയാണെങ്കിൽ just somebody please put it in WhatsApp, okay? So can you see the screen? Can you see the screen? No. This is the question. Now can you see the screen? Now can you see the screen? Screen കാണാമോ? Okay, okay, Taiful. So this is the question. Then you have a ship carrying 48 flags. Okay, and out of this 48 flags, 12 flags of red color and 12 flags of blue color. It includes, there is out of total 48 flags, there are 12 flags of red color, 12 of blue, 12 of black, and 12 of white. Okay, there are four colored flags: red, white, blue, and black. And each of these colored flags, there are 12 colored flags each, and summing up to a total of 48 flags. Okay, then what we want to do is I want to arrange 12 of these flags on a vertical pole. Okay, I want to arrange 12 flags on a vertical pole. On a vertical pole, I want to arrange 12 flags. Okay, when I arrange these 12 flags, up to 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I want to arrange all these 12 flags. And when you arrange these 12 flags, out of total is 48. Total out of 48 flags, I have 12 of red, 12 blue, 12 white, 12 blue, and 12 black. Out of these, I want to arrange 12 flags. From 48, I want to arrange 12 flags so that the question says that there should be even number of blue flags, odd number of black flags. Okay, there should be, when I arrange it, there should be even number of blue flags and odd number of black flags. Okay, other two colors, restriction is there only on blue and black flags. Red and white, there is no restriction. Any number, even whether it is even or odd, no matter, doesn't matter. So this is used to communicate a signal to another ship. So this combination of flags is used to communicate some signal to another ship. So how many such combinations are there? That is what the question asks. So we can solve this using exponential series. So when you solve it using exponential series, let us see how we can do it. See. So to solve this, what we have to do is we have red, white, blue, and black. Okay, so we have to write exponential series corresponding to each of these colors. So the first color is red, isn't it? And is there any restriction on red color? Red and white has no restriction, isn't it? Only for blue and black, they says that it should be even number of blue flags and odd number of black flags. So for red and white, there is no restriction. If red and white has no restriction, then we can write the exponential series as such. We know e raised to x, the exponential series is 1 plus x square by 2 factorial plus x cube by 3 factorial, etc. Isn't it? So this corresponds to the red. So if there is no restriction, write the exponential series as such. Then multiply it with the next color. Next color also, white is also, there is no restriction for white. Again, you can write the exponential series as such. That is 1 plus x square by 2 factorial plus x cube by 3 factorial, etc. Then next, third color, blue flag. And blue flag, they say that there should be even number of blue flags, isn't it? Even number of blue flags. So if it is even number, then the C for the series, we just need to take the even terms. So this becomes, just omit the odd terms and take the even terms. You get 1 plus x cube by 3 factorial plus etc. And next we are going to take the last color, that is black, isn't it? Next is the black color, and for black again it says that it should be blue. Is it even or odd? Even number of blue flags, isn't it? If it is even number of blue flags, you should take the even powers. Okay, blue is even, so you should take the even powers. Okay, so this is this becomes x square by 2 factorial, x raised to 4 by 4 factorial, etc. And for black, it is odd powers. So, or you need only odd number of flags. So, you just take the odd terms, 1 plus x cube by 3 factorial plus etc. So this is the total. This is how you have to. We have to, again. You have to multiply all these. And here, when you look at each term, this implies that this one indicates that there are zero red flags. Then one plus in x indicates that there is one red flag, and 1 plus x square by 2 factorial indicates that there are two red flags. Look at the power, there are two red flags. And if it is only that polynomial is only up to 3, then it indicates that there are 3 red flags. And here this is an infinite series, so that means it can be any number of red flags. Here also it can be any number of white flags. This is an infinite series I had written, because I had written this infinite series because I know the formula for this series. So after writing the formula, from that we will find out the solution. So our question is, there should be a total of 12 flags. Okay, total of 12 flags, and total of 12 flag means I must get the power of x raised to 12. But I will come to it only after solving it using the formula. So now I want to multiply all these polynomials. We know that 1 plus x square, this first polynomial, this series, this is an exponential generating series, so it is e raised to x. This also corresponding to exponential series, e raised to x. This corresponds to an exponential series. It is an odd series, isn't it? Odd powers. So what is the exponential series for odd powers? We had written the exponential series for odd powers, odd and even powers. So even powers, it is e raised to x plus e raised to minus x by 2. If it is odd powers, it is e raised to x minus e raised to minus x by 2. Okay, so we are going to substitute those formulas here. Even powers, you get e raised to x plus e raised to minus x by 2. Then last one is e raised to x minus e raised to minus x by 2. And we are going to multiply all these together. Okay, we are going to multiply all these. That is what we have done in this first step, isn't it? We had written the polynomial, the generating series, and from that we had written the formula for corresponding to each generating series, and we are going to multiply this. Okay, is it clear? Is it clear? So once you have given this question, you have to look whether there is any restriction on these colors. If there is no restriction, the first step is write the exponential series. for that color if there is no restriction as such. Write this entire series. Then white also no restriction. Write the corresponding exponential series including all the terms, all the powers. Then for blue they say that there should be even number of blue flags. So write only the even series. Then for black it says that there are odd number of flags only. So write the odd series, odd terms, and then multiply everything together. And to multiply this, we can reduce it into its formula. That is, the first two terms are the expansions of e raised to x. So e raised to x into e raised to x into even terms means e raised to x plus e raised to minus x by 2. Odd terms means e raised to x minus e raised to minus x by 2. Now we are going to multiply all these together. Is it clear till now? Is it clear till now? Is it clear till now? We are solving problems related to exponential series, okay? Is it clear till now? So if you are given different colored flags, it can be different colored shirts or different colored bags, anything. But when you look at the colors, if there is no restriction given on the color, write the exponential series as such. If there is some restriction, then write the series based on that restriction. If it is given as even, write the even series. If it is given as odd, write the odd series and multiply all these series together. Okay. Any doubts? Hello. So now let us see how to multiply these terms. So you get e raised to x into e raised to x into e raised to x plus e raised to minus x by 2 into e raised to x minus e raised to minus x by 2. This is what we had obtained in the second step, isn't it? This corresponds to red, this corresponds to white, this to black, and this to blue, isn't it? Black and blue. Black, blue and black. Okay. Even is blue. So this is third term is blue and fourth is black. So for black, we need to consider only odd term. So this is the expansion. This is the series corresponding to odd term. For even term, this is the expansion. There is no restriction on red and white. So write the exponential series as such. Now what does this becomes? This becomes e raised to x into e raised to x is e raised to 2x, isn't it? Into. Now I'm going to take these two outside. So 1 by 2, 1 by 2, this becomes 1 by 4. 1 by 4 into e raised to x into e raised to x plus e raised to minus x into e raised to x minus e raised to minus x. Okay. I had multiplied this 2 into 2 and I had taken it, moved it to the left. Then e raised to x into e raised to x is e raised to 2x. Then the remaining terms are these two terms. Okay, now what this form? Can you generalize this form now? This is a plus b into a minus b form. So what will it become? E raised to 2x into a plus b into a minus b is a square minus b square. That is e raised to 2x minus, what is this? A plus b into a minus b, a square minus b square. What will you get? What will you get? A square minus b. What is b here? This is a. And when I took the square of it, the whole square, e raised to x, the whole square, you get e raised to 2x. Now this is e raised to minus x, the whole square, you will get e raised to minus 2x. Isn't it? Any doubts? Any doubts on this? Hello? So, Next, so I've written this step e raised to 2x minus e raised to minus 2x. Okay. Now I'm multiplying this e raised to 2x. I'm multiplying this e raised to 2x. That is, I'll get 1 by 4 into e raised to 4x. Okay, 1 by 4 into e raised to 4x minus 1, isn't it? When I multiply these two terms, 2x into 2x, I'll get 4x. Then e raised to minus 2x into e raised to 2x. This becomes, you add the powers, minus 2x and plus 2x. You get e raised to 0, and that is 1, isn't it? I'm multiplying this e raised to 2x with the inner terms. So e raised to 2x into e raised to 2x, you will get e raised to 4x. Then e raised to 2x into e raised to minus 2x, you get e raised to minus 2x plus 2x. To multiply two powers, you have to add the powers, isn't it? Multiply these two terms, you have to add the powers, you get minus 2x plus 2x. It turns out to be 0. E raised to 0 is 1. So I'll get 1 by 4 into e raised to 4x minus 1. Is it clear? Is it clear? Any doubts? Just note this, okay? This is what is done here in this step. Any doubts? Then I'm going to write it in sigma form, that is the summation form. So in summation form, we can write it as 1 by 4 into sigma I is equal to 0 to infinity e raised to, so this term was e raised to 4x. Okay, it is e raised to 4x. So instead of x, you have to write 4x. See, e raised to x can be written as sigma I is equal to 0 to infinity x raised to I by I factorial. Okay, this is the summation form of e raised to x. E raised to x is equal to sigma I is equal to 0 to infinity x raised to I by I factorial. So if it is e raised to 4x, then this can be written as sigma I is equal to 0 to infinity. Instead of x, write 4x. 4x the whole raised to I by I factorial. So here we can write it as, this is equal to 1 by 4 into sigma I is equal to 0 to infinity 4x raised to I by I factorial. Okay, because you know e raised to x can be written as sigma I is equal to 0 to infinity x raised to I by I factorial. Here what we have is e raised to 4x. So this can be written as sigma I is equal to 0 to infinity 4x the whole raised to I by I factorial. So that is for 1 by 4 into I is equal to 0 to infinity 4x raised to I by I factorial. Okay. Now, this is the general form which we get. 4x raised to I by I factorial. 1 by 4 into I is equal to 1 to 0 to infinity 4x the whole raised to I by I factorial. Now, our question is, I want to find out the coefficient of x raised to 12. Since there are only 12 flags, I have to place 12 flags on a pole. So, I want to find out the coefficient of x raised to 12 by 12 factorial in this polynomial. So, to find out x raised to 12 by 12 factorial, what we should do? See, in this term, we had 1 also, isn't it? It was 1 by 4 into e raised to 4x minus 1, isn't it? This was 1 by 4 into e raised to 4x minus 1. And for this, we substituted like e raised to x is equal to sigma I is equal to 0 to infinity x raised to I by I factorial, isn't it? Isn't it? So we can write this instead of x, we have 4x. Instead of x here, we have 4x. So e raised to 4x is equal to sigma I is equal to 0 to infinity 4x the whole raised to I by I factorial. You have to note this formula and substitute it here. You will get 1 by 4 into sigma I is equal to 0 to infinity 4x raised to I by I factorial. This is for this term 4x. Okay. And you have one minus 1 also here. So in order to, the series starts with 1. Okay, so the minus 1 and plus 1 will cancel. All these e raised to x and e raised to 4x series starts with 1 plus x square term. So since there is a minus 1 here, this 1 and the last minus 1 will get cancelled off, so that we can start I from 1 to infinity. So this becomes sigma I is equal to 1 to infinity 4x the whole raised to I by I factorial. Now next what we want to find is the power of 12. Okay, when I is equal to power of 12 means x raised to 12. So when I is equal to 12, we get 1 by 4 into sigma I is equal to 1 to 12. 4x the whole raised to 12 by 12 factorial. We are bothered, no, we are not concerned about other terms. We just want the 12th, the power of 12, that is 4x the whole raised to 12 by 12 factorial. So this becomes 1 by 4 into 4x the whole raised to 12 by 12 factorial. Now, if we take the coefficient of that term, that is 1 by 4 into 4 raised to 12 into x raised to 12 by 12 factorial. If we are removing that, sorry, it's 12 factorial, then the coefficient of x raised to 12 by 12 factorial is 1 by 4 into 4 raised to 12, and that is equal to 4 raised to 11. Okay, so the total number of flags is equal to 4 raised, the total number of combination of flags is 4 raised to 11 flags. Okay, do you want me to repeat from this step? Did you understand till this step? Did you understand till this step? Hello? You want me to repeat this? Did you understand till this step? What I did till here? Anyone? No response? I think we had just substituted the formula for a plus b into a minus b here, and then I multiplied it 1 by 4, and this e raised to 2x I multiplied with both the terms. I got e raised to 4x minus e raised to 2x into e raised to minus 2x is 1, because the power, when we add the power, it becomes e raised to 0 and e raised to 0 is 1. So I will get 1 by 4 into e raised to 4x minus 1. When I write it in sigma form, it is 1 by 4 into sigma is equal to 0 to infinity 4x the whole raised to I by I factorial. Okay. So here I had converted this to its summation form. Since e raised to x summation is sigma is equal to 0 to infinity to x raised to I by I factorial, where when we substitute x by 4x, you will get the formula for e raised to 4x as sigma is equal to 0 to infinity 4x the whole raised to I by I factorial, and this minus 1 have to come here, isn't it? Now this series it starts with 1 plus x square by 2 factorial, and when since this 1 is also there at the end, these two 1 will cancel, so that I needn't start from 0, I needs to start only from 1. So this becomes I is equal to 1 by 4 into I is equal to 1 to infinity 4x the whole raised to I by I factorial. My aim is to find out the coefficient of x raised to 12 by 12 factorial. So the coefficient of this term will give the number of flags to be the total number of combination of flags that can be placed on the pole corresponding to this combination. So when I want to find out the power of 12, so just put x as the I is equal to 12 in this equation. I will get 1 by 4 into 4x the whole raised to 12 by 12 factorial. 1 by 4 sigma I is equal to 1 to infinity 4x the whole raised to I by I factorial. I got till this point, isn't it? Now I want to find out the coefficient of x raised to 12 by 12 factorial in the series. So to find out the power of x raised to 12, just put I is equal to 12, and I will get 1 by 4 into 4x the whole raised to 12 by 12 factorial. That is 1 by 4 into 4 raised to 12 into x raised to 12 by 12 factorial. So this is the series, this is a term in the series, and this is the coefficient of the series of that term. And this coefficient indicates the total number of combination, and that is 1 by 4 into 4 raised to 12. 1, 4 and 4 will cancel. I will get 4 raised to 11 combination. This is the coefficient of x raised to 12 by 12 factorial, and this number of flags will be there. This number of combination of flags can be hoisted given the condition based on that question. You have total number of combinations of flags that can be chosen is 4 raised to 11. Okay. So once you are asked to find out 12 number of flags, then you have to find out the coefficient of x raised to 12 in the exponential series. If you are asked to find out if there are 15 flags to be hoisted, then you have to find out the coefficient of x raised to 15 in the exponential series. So each term in the series represent the number of flags that should be hoisted. Okay, is it clear? So the next sub question, for this the next sub question is, how many of these signals have at least 3 flags or no white flags at all? Okay, that is the second sub question. The same way we can solve the second sub question also. Did you understand this question? Did you at least understand the steps in the question? Hello? Agarsh. Okay, Isha. Okay. We are just looking at the series and just writing the series as such if there is no restriction. If there is restriction saying that there are even number, then we are writing the even series, then the odd series, multiply everything together and you solve it, and you are asked to find the power of 12. You have to place 12 flags, so just find the coefficient of x raised to 12 by 12 factorial from that series. That is the general steps here. Okay. If anyone didn't understand, just ask me later. Okay. Then number one, attendance.
1,
Two,
2,
Three.
3.
Three.
Okay. 4. Number 4. Absent.
5.
6.
7.
8.
9.
10.
11.
12.
13.
14. 14
15.
absent. 15 okay is present. 16 absent. 14 present okay. 16 absent. 17 present. Next 18.
18.
19.
20 present. Next
21.
22 present. Then 23.
23. 24.
25.
26.
27
27.
absent.
28.
27 present.
28.
Okay.
30.
29 present. 30 present.
31.
Okay.
32.
Okay.
33.
Next
35.
34. 35.
36.
Okay. 37.
37.
37.
37.
Okay. Next
38.
39 present. 40 present. 41.
41.
42. 43.
44.
45.
46.
47.
48.
49.
50 present. 51.
51.
52.
53.
52
55.
present. 50.
55.
Okay.
56.
Okay.
57.
Okay. 58.
58.
Okay. 58. 59. 59. 60.
59.
61. 62.
62.
63. Absent. So absent is number 4. 4 Agna. Present. Okay. Number 16. Number 16 and 63. 16 present. 63. Okay, thank you.